Welcome to the Power Tech podcast, where we discuss all things related to power supplies. Today, we're going to dive into the world of noise and power converters. Then we'll look at linear and switch mode power supplies. These two types of power supplies are widely used in a variety of applications, from chargers for our smartphones to power supplies for industrial processes. Introduction to noise and power converters. Noise is an unwanted disturbance in an electric signal that can negatively impact the performance of power converters. There are two main types of noise and power converters: electrical noise and magnetic noise. Electrical noise is caused by high-frequency signals that are generated within the power converter itself, while magnetic noise is caused by the interaction between the power converter and other electrical components in the system. Both types of noise can interfere with the quality of the output of the signal, leading to a range of problems such as increased power losses, reduced efficiency, and in extreme cases, system failure. Causes of noise in power converters. Noise in power converters can be caused by a variety of factors, including the design of the power converter itself, the quality of the components used, and the operating conditions of the system. For example, noise can be generated by the high-frequency switching in power converters, electromagnetic interference from other electrical devices, or even power quality issues such as voltage spikes or brownouts. Fortunately for us, there are several strategies and techniques that can be used to mitigate noise in power converters. These include using high-quality components, optimizing the power converter design, implementing filtering and shielding techniques. Other techniques, such as using a low-noise power supply, reducing the switching frequency, reducing the output voltage, can also help to reduce noise levels. Let's look at linear and switch mode power supplies in the context of noise. Linear power supplies, as the name suggests, work on a linear regulation principle, meaning that the output voltage is proportional to the input voltage. Linear power supplies are known for their simplicity and high level of stability, making them ideal for applications that require low noise and low ripple in the output voltage. Unlike linear power supplies, switch mode power supplies, SMPS, work on a switching regulation principle, meaning the input voltage is rapidly switched on and off, creating a high frequency square wave. This high frequency wave is then converted into the required DC voltage using a series of components, such as transformers, inductors, and capacitors. The result is a power supply that is much more efficient, lighter, and smaller compared to linear power supplies. However, this high-frequency switching process itself can generate a lot of noise. Each type of power supply has its own advantages and disadvantages. For example, linear power supplies are known for their high stability and low noise, but they're generally less efficient and larger compared to switch mode power supplies. On the other hand, switch mode power supplies are more efficient and smaller, but they can generate more electrical noise and have higher output ripple compared to linear power supplies. That's all for today's episode of Power Tech. We hope you found this discussion on linear and switch mode power supplies to be informative and interesting. If you have any questions or comments, feel free to reach out. Until next time, keep powering up.